Whenever you're asked to calculate anything with scientific notation, it's a good idea to understand the rules and basic principles behind this. A lot of times students just use their calculator, but understanding the rules and methods behind calculating with scientific notation often helps you not to make mistakes, as well as sometimes it saves you a lot of time. There's two main methods of calculating. There's adding and subtracting, and multiplying and dividing. Let's start with adding and subtracting. Whenever you're taking two numbers that are in scientific notation, the first thing you want to check to make sure is that both numbers are in the same power of 10. You can't add the coefficients together or the bases together unless the powers of 10 are the same. Once that's done, you'll add the m values together. If your resulting m value is not between 1 and 10, you're going to have to move the decimal and change the power of 10 to correspond. Because remember, scientific notation always has the base number as a number between 1 and 10. So let's take a look at an example. 9.99 times 10 to the 7th plus 3.87 times 10 to the 8th. A lot of students will use their calculator for this, and that's fine, but understanding how to do this problem without a calculator is also a helpful tip. If you look at these two numbers, you might be tempted to think that the first number is actually larger, since the base number is larger than the base number in the second number. However, when you take into consideration the factors of 10, the second number is actually larger because it has 10 to the 8th, whereas the first one is 10 to the 7th. That's why it's important to make sure that the powers are in the same power of 10. The general rule is you want to convert the power to the highest power of 10. So in this example, 10 to the 8th is the largest power. So we're going to be converting the first number in order to be written in the form of 10 to the 8th. It's really easy to make sure that this is done correctly. If the exponent is getting larger, the number must be getting smaller. So if we're going to be changing the first number to be something times 10 to the 8th, or in other words, we're making the exponent one place higher, we're going to actually move the decimal place one place in order to make it a smaller number. So it's going to be 0.999 times 10 to the 8th plus 3.87 times 10 to the 8th. Now that both numbers have the same power of 10, we can take the m value, which is 0.999, and 3.87, and we can add them together. When I add them together, I get 4.869. But remember, we need to take significant figures into account. When you're adding and subtracting numbers, the sig fig rules is we need to keep the lowest number of decimal places. This number has 3 decimal places, whereas this number has 2 decimal places. So I'm going to have to rewrite 4.869 to be 4.87. Times 10, and here's the important part, the times 10 is to the 8th. You do not multiply or change the exponents. The reason why you got them both in the same exponent or power of 8 is so that you could add them together. So the answer to adding these two numbers together would be 4.87 times 10 to the 8th. Now let's take a look at multiplying and dividing. Most of the time this is the operations you'll be working with. The first thing we want to do is we want to perform the multiplication or division between the two m values of the numbers that you're multiplying or dividing by. If you're going to multiply, you want to make sure you add the exponents together. If you're dividing, you're going to subtract the exponents. Once again, make sure your m value in your answer is a number between 1 and 10. So let's take a look at the example below. We have two numbers that are written in scientific notation that we need to multiply. 2.0 times 10 to the 3rd times 6.0 times 10 to the 5th. Since we're multiplying, we're going to take our two base numbers, 2.0 and 6.0, and we're going to multiply them together. 2 times 6 is going to give me the number 12. When I'm multiplying, my sig fig rules is to keep the lowest number of sig figs. And so both of these numbers, 2.0 and 6.0, have 2 sig figs. And 12 is 2 sig figs as well. Now, let's go ahead and add on the times 10. Times 10, and since we're multiplying, we're going to take our two exponents, 3 and 5, and we're going to add them together. That means that my exponent is going to be times 10 to the 8th. All right, we're almost done. We have our sig figs. We know our math is correct, but it's not written correctly. Notice the base number is not a number between 1 and 10. It's actually greater than 10. We need to make sure this is written correctly. So the obvious thing would be to put the decimal between 1 and 2, making it 1.2. Now, notice what I did. I moved the decimal in such a way where I moved it one place to the left, and I resulted by making the number smaller. It went from 12 to 1.2. If the number got smaller, then that means the exponent must get larger. And the exponent gets larger by however many places you move the decimal. In this case, we moved it once. So that means the exponent is going to be 1 up, or times 10 to the ninth.